The lesson outcome for this video is, I can solve linear inequalities by graphing. And this is day 2 of this topic. So we already practiced these steps yesterday or previous day, and now we are going to just try a few more complex examples. So let's go over our steps first of all. First of all, step 1, what form is it in? It's best to know what form your inequality is in so that you're ready to graph it. Step 2, graph some points. And we're going to get those points from knowing what form it's in, and we're going to use our normal methods for that. Step 3, is the line solid or is it dashed? Remember, that is dependent on this sign right here. The inequality sign tells you if it's dashed or solid. And step 4, we're going to test a point. Put in a point right here. We're going to test it out in the inequality, decide if it's true or false, and shade based on our answers. So step 1, what form is it in? Well, this is in standard form. If you look at the inequality above, we have negative 2x plus y is less than negative 6. So we are going to, in standard form, typically use our teeny tiny table of values, and we only need 2. And we use our x and y intercepts. So we're going to find our y-intercept by putting in, and let's use, sorry here, we're going to put a 0 in for x to find our y-intercept, and we're going to put a 0 in for y to find our x-intercept. So when I put a 0 in for x right here, I get, negative 2 times 0. So negative 2 times 0 right here, that becomes 0. We don't have to worry about that right now. So then we just have y is less than negative 6. Now don't worry about the less than part of this right now. We just know that we're going to put negative 6 in for our y-intercept. Alright, then we're going to go along to the next part, and we're going to put a 0 in for y. So I'll put a 0 in for y right here. Well, adding 0 right here becomes just 0, so we don't have to worry about that. And now we have negative 2x is less than negative 6. Again, don't worry about that less than symbol right now. Just treat it like an equal sign. So we divide both sides by negative 2, and we get x equals 3. All right. So now, as it says, we are going to graph some points, meaning those points that we just found in our table. Our first point is 0, negative 6. So 0 on the x-axis, negative 6 on the y-axis. Hopefully you're finding that with your eyes. That's right here. And then 3, 0, 3 on the x-axis, 0 on the y-axis is this point right here. And now before we start drawing that line in, we want to decide if it's solid or dashed when we draw the line. Again, that comes back up to, whoops, sorry, I was looking for my eraser. That comes back to up here. I guess I can't erase that now, sorry. That comes to right here, the less than symbol. It's not less than or equal to, it's just less than, which means that our line is going to be dashed. So when we draw our line, we're going to draw that dashed. Like so. And then the last step is we have to test a point or plug in a point into the inequality and then decide if it's true or false and shade based on our decision or based on whether it's true or false. So like I said, I can't really get rid of my shading in here, sorry about that, but I'll go ahead and rewrite our inequality. Negative 2x plus y is less than negative 6. If you remember from a previous lesson, the best point to test is 0, 0. If you remember that, it's going to be easier for you typically. So let's test the point 0, 0. That is the origin, that's this point right here. We're going to find out if that should be shaded or not shaded. So if I put a 0 and a 0 in, I'm going to go ahead and do that right here. I put the 0 in for x, I put a 0 in for y, and now I have to decide if this is true or false. So negative 2 times 0 is 0, plus 0 is 0. So what we really have here is 0 is less than negative 6. Oops, sorry. All right, so is 0 less than negative 6? No, it is not. This is a false statement. And because it's false, we do not want to shade this point right here because it's false. It was not true for this point, so it's not true for anything on this side of the line. So our shading is going to exist on the other side of our line, which is this region over here. All right, another example. 3y is greater than or equal to negative 4x plus 3. The first question, what form is it in? It's actually not in any of the three forms we're used to graphing. It's not in standard form because the x and the y are not on the same side. It's not in point slope form because there's no parentheses. And it's very close to slope intercept form except for this 3 in front of y. So we need to deal with that 3 so that y is alone. All right. So what we need to do is we need to simply divide this side by 3 and then divide this side right here by 3 as well. But remember that means you divide both parts by 3. So what I'm going to do is I'm going to divide this by 3 and I'm going to divide this by 3. Now 3 divided by 3 is 1, so we're going to be left with 1y. We do not need to flip our inequality sign, so we'll just leave it as greater than or equal to because we only divided by a positive 3, not a negative 3. And then we're going to rewrite this as negative 4/3 x. And then we've got here 3 over 3, which is 1. So plus 1. Now this is in slope-intercept form. So what form is this in? Slope-intercept. And we know that if it's in slope-intercept form, we want to find the slope and find the intercept, which is the y-intercept, and graph it. Our slope is found right here, so negative 4/3. And our y-intercept is found right here, which is 1. We're going to begin with the y-intercept, which is 1, and we're going to put that on our y-axis, not our x-axis. And then we're going to use our slope of negative 4/3 to graph another point. So we're going to go down 4 and right 3, which is what I moved there, down 4 and right 3. And now we want to decide, before we graph our line, is it solid or dashed? Because this sign is greater than or equal to, it means that it's going to be a solid line. I'm going to carefully draw my solid line. I'm going to try that again. Okay, there's my line. And the last step is we need to test a point, plug in a point, test it out, see if it's true or false, and then decide on our shading. I'm going to again use 0, 0. Every time possible, I'm going to use that. It is the easiest point to use. So I'm going to go ahead and use 0, 0 right here. Going to my equation, my inequality, excuse me, I'm going to put a 0 in for y is greater than or equal to negative 4/3. And we've got our x, which is 0, and then plus 1. Again, the zeros make things really easy. This will be staying a 0. This will become a 0 plus 1. So we've got 0 is greater than or equal to 1. Again, this right here all became 0. So 0 plus 1 is 1. Is 0 greater than or equal to 1? Nope, it is not. 0 is not greater than or equal to 1. It's false. Since it's false, we cannot shade that point that we tested. Again, we tested this point right here. We cannot shade that point because it's false. So our shading is going to occur away from that point. And there is our solution. All right, one last example. Go ahead and pause the video, give this one a try, then restart it and check to see how you did. All right, so first of all, I hope you decided that the form that this is in is standard form. Okay, if you weren't sure, maybe you can pause the video now and give it a try. But standard form, again, we always graph by using our teeny tiny table. I'm going to put a 0 in for x and find my y, and I'm going to put a 0 in for y and find my x intercepts. All right, so if I put a 0 in for x right here, well, that's 1/3 times 0. This all becomes 0. Be very careful about this negative sign right here. So we have a negative y is greater than 4. We would have to divide both sides by -1. So picture it like -1 here, -1 here. Those cancel. We're going to be left with y. The inequality technically would flip, so we'd have y is less than 4 divided by -1, which is -4. It doesn't really matter that it flips because we're going to decide on our graphing later. So -4. Okay. And now the second thing we're going to do is put a 0 in for y right here. And again, that means we're subtracting nothing. If we're subtracting nothing, that doesn't do anything for the situation. So now we have 1/3 x is greater than 4. Now to get x alone, remember we'd have to divide both sides by 1/3. A lot of times people make mistakes with that. Remember that another option is to multiply by the reciprocal on both sides. The 3's will cancel and make 1's, and therefore we're going to have x is greater than 4 times 3 over 1, which is 4 times 3, which is 12. So x is greater than 12, which means that we can use 12 for our x-intercept. All right, so we're going to plot our points. I notice now that 1 is not going to fit on our graph, our coordinate plane shown here, but we'll make it work. 0, -4 for our y-intercept is right here. And then our other one is 12, 0, and that will be off over here for 12. Okay. And then we have to decide if the graph is going to be, the line is going to be solid or dashed. Again, based on this symbol right here, it's going to be dashed. I'll go ahead and make my dashed line here. There we go. And now we are going to once again test a point and see if it's true or false. So I'm going to use 0, 0 every time I'm possibly able to. The only time I wouldn't be able to is if the graph, the line itself, went through the origin. Then that wouldn't work. But I've got 0, 0 that will work this time. So I've got 1/3 times an x value of 0 minus 0 is greater than 4. So we've got 1/3 times 0, which is 0, and then 0 minus 0. So we have 0 is greater than 4. False. 0 is not greater than 4. So if it's false, we do not shade this point right here, so we should shade the other direction. So our shading will go over here.